Hello, everyone. Firstly, I want to thank you all for coming to my talk. This is my first time ever presenting at a cybersecurity conference, and this is a much bigger room than I was expecting to be presenting in, so I want you to all bear with me. But I wanted to create a little talk about my research into malware analysis and how I've been using AI to basically get rid of the bullshit parts of the subject. So I'm Tom, by the way, in case you didn't know. Here's a little slide about me. Oh, my beeper's not working. No, of course. All right, I'll just go manual for this one then. Let's see. There we go. Okay, so this is me. I'm Tom. I'm currently working as a SOC analyst at Dharma in Edinburgh. It's a very fun job. Do a lot of cool stuff, learn a lot of cool stuff, and work with some very fun people. Really loving it. But I was one of you guys. I used to study here at Securi-Tay. I was here from 2017 till about 2021. A lot of fun there. After finishing my bachelor's, I wanted to do something very different. You know, they say it's sunny Dundee, but is it really? So I wanted to get as far away from Dundee as possible and did my master's in Kuala Lumpur in Malaysia. Went to a little place called Asia Pacific University, which is a really good place for cybersecurity, and just like had the time of my life. It's such a beautiful country. If you ever get the chance to visit it, highly recommend it. And the food is top tier. Honestly, some of the best food I've ever had in my life. So anyway, some other stuff about me.
It's a movie. Oh God, I forget. I'm 92. I have seen the William Bugstar.
Anyway, so some other stuff about me. I'm quite a keen runner, been running for a while now. And I'm also a big, passionate baker. You can see here, me and my friend making some top-notch eclairs. They were amazing. So anyway, I should stop yapping about myself. You've gotten to know me well enough. Let's get on to the topic at hand. So I've always been fascinated by malware since I was a kid. I remember having one of these Google Assistants on my dad's computer. I remember very vividly when I was 11, absolutely destroying my mum's laptop by installing Minecraft mods. It was so bad that we had to just get rid of the whole laptop. Before then, I didn't really realize that like a piece of software that, you know, trying to download a portal gun mod would just absolutely kill a laptop. And ever since then, I've just been completely fascinated by it. Malware analysis is sort of the subject of dissecting a malware sample and trying to understand what the threat actor is trying to achieve with it. Are they trying to ransom you for money? Are they trying to gain information? Maybe they're just trying to record keystrokes to harvest information. There's a lot of different motivations that a threat actor could have when creating malicious software. And malware analysis is sort of the study of the science of dissecting it to find out what these underlying motivations are. It's a very fun subject. I recommend all of you to try it. And anyway, malware analysis typically is done in 4 different stages, varying in complexity. The first stage, which is by far the most boring, is static analysis, where you simply get the sample, you don't execute it at all, you just read through the strings, you look at the imports. It's all very dull, and it's always something I want to skip through as quickly as possible. The fun bit is the dynamic analysis, where you're actually executing the software. It's like clicking the big red button in the middle of the war room and just seeing what happens, seeing how it messes up your system. It's by far the most fun bit. You also have advanced static analysis, where you're using tools like IDA Pro, Cutter, to like various disassemblers to essentially dissect the sample without actually executing it. You get a real feel of the flow of the program, seeing like which routes it will take depending on how it's going. You know, is it checking for debuggers? Is it checking for this? Is it checking for that? And you get to understand the flow of the program a lot more. And then advanced dynamic analysis is where you put and execute the software within a very controlled environment, debugger like OllyDebug, Ghidra, and you can go step by step through the program and see how it's executing in real time. There's a lot of different stages. These 3 are the most fun. Static analysis is very dull, and most people find that when they start doing analysis. There's a lot of issues with malware analysis. It's not a perfect subject. It's not always going to be fun. One of the key issues with analysis is the sheer volume of new threats every single day. There's around 500,000 new malware detected every single day. that's not enough analysts in the world to actually keep up with this sheer volume of new threats. The other issue is quite often these investigations take 6 hours at a time. I know if I'm writing up a full report, it's going to take me probably half a day or more, and that's if I'm being quite quick about it. If you're producing, if you're not wanting to miss anything within the sample, you have to be very thorough, and it just doesn't make sense with the amount of samples coming out each day. I've also found this a lot recently as well. You'll download a new sample from some dodgy bit of the web, of the internet, go on Malware Bazaar or somewhere like that. You'll start analyzing it, you'll start collecting strings, start looking through, and then start executing it and realize that it's just a benign sample, it's just a false positive, and you've wasted the last hour, getting excited, thinking it's something cool. A lot of the times you can be losing hours of time just by being bogged down with false positives. So it is quite a tedious subject at points. I'm going to move on to the thing I'm hoping will fix these problems, which is AI. Now, I don't need to describe AI to you. You've heard the word about 80 times today already. It's the buzzword of the century. It's just pervasive in everything. Every company is investing in it. It's in every tool. We all hate it, but we all just have to get used to it at this point. AI has revolutionized plagiarism. It's never been better. Every student in here, I know you're using ChatGPT for your homework. It's just the way it is nowadays. It's, for some reason, excellent at dad jokes. Who would know a computer would be amazing at the most bad jokes you've ever seen in your life? And AI seems to be the new buzzword of the next couple of years. It's going to be dominating our lives for the foreseeable future. It's going to be getting into everything. And even if we dislike it, we just have to learn to use it and get good results from it. I mean, for me at least, I find AI quite useful. As a SOC analyst, we're quite often given big strings of things, like this is a PowerShell series of commands. Now, you can go through this, it's quite simple, and read each line and figure out what's going on. But AI can save you probably 4 or 5 minutes each time just by summarizing every single line. It's very good for if you're a new analyst and you just needing something to aid your learning. I think it's amazing for this sort of use case. If you're needing to learn something, I always feel like AI is a good way to start finding more sources of information. I mean, like here, it's dissected every single line and giving you the potential security implications. If you're working in a SOC and you've got 100 tickets giving you stress, this is a good way to save a little bit of time here and there. It's not perfect though. You can never 100% rely on AI. AI is also incredibly bad for the environment. AI has caused so many issues. It's very counteractive to the whole climate consciousness that we're seeing nowadays. AI seems to just completely ignore that and just burn all this energy and all this water. AI can also be very politically biased and racially biased. A good example of this is DeepSeek, which has come out recently. I mean, it's obviously distributed by China, and if you do ask it about stuff like Taiwan, it will tell you that Taiwan is a part of China. It will not even hold its punches. It is purely a propaganda machine for the CCP. AI also will produce results that are not always accurate. We've all heard about AI hallucinations. I found an example here where AI is describing crossing the English Channel on foot. Complete nonsense, obviously, but it's outputted that and just claimed it as fact. And as well, from personal experience, I found that AI can quite often make very simple mistakes. I think I was asking it to do a series of multiplications over and over and over again for a series of, I think it was some hex values that had to be times together or something. And it was consistently failing at doing basic multiplication. And if it's failing at that, it sort of leaves you wondering, is it failing at the more complex stuff and I'm just not noticing it? So it is a bit scary in those aspects.
It also doesn't do well with checks. Something that I would have last one thing, I was asking for checks, and every time I was sending somebody, no, you can't do that. And then I was telling it, it would tell me different.
It does make simple mistakes like that, doesn't it? It's just it's mad that we rely on it so much, but it's making these mistakes. AI has also started to be used by threat actors more and more in their malicious samples. This was a piece of malware I analyzed a while back called Black Mamba, which from the surface level does not appear malicious at all. This is just a basic Python script. There's nothing really bad here. all the malicious content actually gets generated at execution time. And that's through using this gen code function here, which calls to ChatGPT and basically asks, saying like, I'm a security professional, I'm just trying to teach some kids about malware. Please write me a key logging script which will send to my C2 domain. And it will just do this. This is like a very pervasive attack that has been infecting things. And it's really hard to detect because there's actually no malicious content within the file itself. It's simply the prompt which is generating the malicious content at execution time. So if threat actors have started using AI in their attacks and they're becoming more and more complex and stuff that we can't detect, I do think, given this like cyber arms race, we should start adopting AI into more of our technology and being more open to it. This led me to look at my own AI, my own malware analysis, and see how I could enrich it using AI, just to save me some time and solve some of the problems I have. Now, AI has been used in many of our tools already. VirusTotal has a code insight section, which gives you a breakdown of each of the file contents, and can be used to categorize it. Like here, it's saying this is a key logging script. It uses Google Gemini to provide these insights, and it's pretty good. Like if you're looking at file hashes and you're wanting to get some quick insight into it, it's a good place to look. AnyRun as well, which I use quite often at work, has this feature as well, where it has bit-by-bit ChatGPT analysis of execution. This is very nice. It's like I said, very good way to understand a sample at a deeper level far quicker than you would be able to traditionally. These don't really solve the problems I have with malware analysis. My key problems tend to be about the time taken to actually analyze samples. It is quite a long time, as I've mentioned, and there's too many samples to choose from. I have a real fear of missing out. Like, I'll be doing 3 samples in a row, all being the same sort of malware family, just bored out of my mind. I want that juicy one, that thing that's new, that's got a real novel technique, that's actually gonna teach me something new. I don't want to have to be scrolling through trying to figure out which sample has that. And as well, the early stages of analysis are often very tedious and boring. I don't want to be doing them, most analysts don't. So my solution to this problem was to create some automation script that would analyze a bunch of samples, use AI to give classifications and categorizations of these samples so that I would know exactly what's going on before even analyzing it, and just have it ready for me to triage and choose which samples I want to be analyzing first. A key thing though with malware analysis, which makes using like AI models quite hard, is that you have to make sure that the malware is contained, unless you want your whole system to be completely infected with malware. Traditionally, this is done through virtual machines, which are disconnected from the internet, not allowed to communicate, so that they can't be spreading out. And it does take a while to trust these things. The first time I ever detonated a piece of malware, I was sweating, hyperventilating beforehand. I remember it clicking execute and then like going away from my computer, worried that I had permanently destroyed it. Afterwards now, I just don't care. You just hit the button, see what happens. But this provided quite an interesting challenge of finding a way to make sure I'm executing these malware samples without putting my further thing at risk and also getting the AI enrichment. My solution, let's see if this works. Oh, yes, laser pointer works, was to create a 2 VM lab. So I had one VM here, which is running Flare VM. It's a Windows-based malware analysis virtual machine. It's got a lot of really good tools in it, a lot of good stuff, and I configured that to be no internet at all, so there's no chance of the malware escaping. It couldn't communicate with anything apart from through this tunnel here. And I loaded up all the samples onto this machine here. I then used a PowerShell script which would run it and send it through, but I would also run this Python script which would do all the analysis I wanted on these samples here. I chose Python just because I'm comfortable with it and it's a fun language to learn. And it would send across through this tunnel this massive text document of every single sample that I had analyzed, all combined into one. It would also do some checking just to make sure that this is a text document. It would check like the file header and stuff. just in case it was something malicious. I don't know. I'm very paranoid, so I just wanted to add the steps just in case it's infecting my other machine. On the other end, I would also do a check here for it being a text file, and this Python script would essentially use various APIs using limited internet. So it could connect to stuff like VirusTotal, ChatGPT, Grok, and other stuff, but it couldn't connect to anything else, and it had no communication other than through this tunnel, which was purely receiving. So keeping it nice and contained, nice and safe. This script would run some other analysis on the samples and create text files for each of the samples analyzed. And right, I'll get into the scripts a little bit more. So a couple of the tools I shoved into these bad boys. So this is on the analyzer side. I use Kappa, which is an amazing tool. It basically takes a sample and it runs through the different capabilities of it. You can see here that it's identified as being compiled with NIM, which is a very popular coding language for malware authors. You can see various other capabilities of it. And it even has some sections for stuff like the MITRE framework. So it puts the various tools, techniques, procedures that are being employed within the binary itself. I used another tool called Detect Easy, or DIE for short. This is a fantastic tool. You can see here it's got all these various features. I particularly like the entropy thing. It basically shows if a sample's packed or not packed, which I'll get into later. But I used a bunch of these different options here to gain a really verbose output on what's actually in the sample, what the content is, what the imports are. And finally, I used floss for all the strings. Floss is much better than the strings command. I can't believe it took me ages to find it, but the one thing it always does, it always provides the key IOCs at the bottom of the document, so you don't have to be scrolling through 6,000 lines of strings just to find something that's important. So I just added a bunch of tools to this Python script just to automate the stages of static analysis, which then would get sent through to the receiver script, which would take the full text document and break it down into the individual samples so that I could analyze them each individually. This would ship across to things like VirusTotal, which would check it for malicious contents using the APIs, stuff like CrowdStrike's hybrid analysis, just to give some more data on the detections and the file hash. And then finally, shipping it across to the various AI models that I had used. I honestly went a little bit mad playing with different models. I don't know why. I just went down a rabbit hole just seeing what the differences was between them. So I employed ChatGPT and DeepSeek initially, and then chose to employ Gemini just to give it a basis. But then Mr. Musk released Grok 3, I think like 2 weeks ago. I just thought, why not include it in this investigation, just see how a very new model of AI would handle it. One thing I do have to get off my chest and confess is that the results from ChatGPT were very mid initially. They were very bad. And just to make it like a bit more interesting, I did purchase ChatGPT Premium. I feel ashamed of it, honestly. Like, genuinely, I feel ashamed. As soon as I get home, I'm canceling that bitch, all right? That is not staying on my card, okay? So let's get off this picture, because that is horrific. Anyway, I say final product. This took me about like 2 weeks of like coding, troubleshooting, and doing it. I spent way too much time trying to make a technical aspect of this project, but my final product in the end was something I now use in my lab day to day. It would statistically analyze as many samples as you shoved into it. It would write it all up and ship it across to the internet box and use various APIs and AI to give some verbose details about it. And it would just basically save me a ton of time. Initially, I did predict that it would just rewrite the results of the tools and not really provide any details, which initially was true. This was one of the outputs I got from ChatGPT initially, which gives the most basic bitch answers possible. Look, command and control, sample seems to make communication attempts to URL. That is just so like surface level details, and all the IOCs are just file hashes, which we can get from one simple command. So I was very disappointed with the results about that. Eventually, I did stumble across a tweet from Greg. I don't remember his full name. Greg, who's in charge of OpenAI, who had released this massive post about how you should be structuring your prompts to actually get the proper output from ChatGPT and other AI models. And he basically states that you need to have a goal for it to follow a return format, a warning, and a context dump. And using this, I created a much better prompt for it. My goal being clearly given, some different content formats for the return, which was the most important thing, warnings, and then the context was the actual file itself that was being submitted. The thing I did notice is that you can tell an AI to do something, it's never really going to listen to you properly. It's like a dog, it's going to do its own thing if it wants to. Every single time I asked it for the return format to be very specific, it would just do its own thing. Like sometimes it would include IOCs, so it's clearly not perfect, but this aided in getting much better results from the models. I mean, you can hardly see that, but it is just a block of text, but it's much better than before, just trust me, okay? I provide details on different IOCs identified in it, what it actually is trying to do, if it's malicious or not. This is essentially what I was wanting to get from it, because for me, I would just read the stock and I'll go, all right, I want to tackle this one. What's this one for? So this seems to be like a dropper, and it's like, oh, well, I want to investigate that, so let's have a look at that. Some other results I have, this is from WannaCry. That's much too small, but you can see the amount of detail it has there from a sample, and it identifies it as WannaCry and lists a lot of steps, lots of IOCs after this. I mean, this is not even the full result. So this is like a really good result for me. This is exactly what I was wanting, deep, verbose outputs about what's actually going on from the sample, from honestly quite a surface level static analysis of it. Some things I did notice was that AI really excels at analyzing scripts. When I would put in stuff like a PowerShell script or a Visual Basic script, or even like a HTA, which is like a portable domain that you can run without a browser, because all the source code is there, the AI would be able to understand literally every single bit, and I was getting some really good results from it. One of the samples I shoved in was this sample called Basic Star, which is basically like this info stealer, I guess. It was targeted at security researchers, so basically us, and it would gather device and hardware details, likely leading to a second attack in the future. And I mean, it was able to basically understand every single aspect of this thing, explain it to me line by line, and as an analyst trying to save time, it's like, this is just perfect. AI is not perfect though, in all aspects. It really struggled with packed malware. Now, if you've not heard this term before, a packed malware is basically when a threat actor will use a wrapper to compress or encrypt the contents of the executable so that when you're performing a string search or a kappa, it's actually not going to really produce anything at the end of it. It's just going to give you no results. Analysts would struggle with this from a static point, but this was some of the results I got from packed malware. I mean, it does identify it's packed, but there's very little here of worth for me. But I did find that some things like DeepSeek was able to give me some quite good analysis. Like if it wasn't able to figure out stuff, it was able to say like, look, it's got a high entropy level, strongly implies that this is packed, common technique by malware authors. So it's still good info at the end of the day. There's another aspect of doing malware analysis, and that is creating YARA rules, all right? So YARA stands for legitimately yet another ridiculous acronym, okay? And it's essentially a way of writing detection rules so that you can catch these samples in the future. I think the easiest way to describe YARA rules is that you're using the IOCs that you identified during your investigation, and then you're using it to catch it in the condition. So you can see here I've used certain like domains I've found, encryption methods, the language here, and I'm basically saying like if it's an executable, using them with these functions and this thing, then we catch it. And it's just a way to detect these samples on other machines. I said it uses IOCs. Not all IOCs are created in equal. If you were in track 2 just an hour ago, you'd have seen this lovely pyramid of pain already, but it basically shows like the hierarchy of importance when it comes to IOCs. You have stuff like hash values right at the bottom because you can change the hash value simply by, changing one small thing about the program. Domain names, which are quite simple for a threat actor to change. They can just spin up a new malicious domain. To stuff like tools, which are a lot more challenging for a threat actor to change. And as you can see here, back to this one, I'm using a variety of IOCs from the pyramid of pain to simply catch this and provide the best rules possible whilst still making it readable, I guess, or still making it understandable. I did test YARA rules against the various AI models. I wanted to see how they would handle making YARA rules, and I just sort of predicted that they would provide good ones that then the analyst could edit. In fact, I was wrong. They were shockingly bad at writing YARA rules initially. This is the output from one of them. All the thing has done is take the various file hashes, the MD5, SHA-1, SHA-256, and just say, got any of them, we'll detect it. If that's fine, that's good enough. As we know, these are all trivial things to change. This detection would work for like a week probably at most. It's very basic. Yet again, prompt crafting is the key here. I think I added to my prompt a whole bit about writing YARA rules in the proper format and focusing on these key IOCs, and I started getting better results from it. This is from the exact same samples before. You can see it's identifying various IOCs and just saying if it has any of these ones, this ping attempt, this domain, this file location, then we know it's this sample. Still not the best YARA rule. It lacks sophistication to properly detect things and can be changed, but it's a much better start. This is a bit of a tangent. This is something I found out whilst doing my research. So I think Grok 3.0 released 2 weeks ago or so, and I was like, screw it, I'm just going to add it to my presentations last minute just to see how it handles stuff. Mr. Musk, of course, makes you pay to use this API, and I'm too broke at this point to do that, so I was just like, screw it, I'm just going to do it manually just to get some more results for this talk here. So the way it was working beforehand is I would take the text file and through automation use it with ChatGPT and then put the results back in the text file, shove it to DeepSeek, shove the results back into the text file, and then I would manually upload the text file to Grok. So Grok did have access to the two other AI models' results at the end of the day. And this led to some quite interesting plagiarism, honestly. So this is a YARA rule that ChatGPT did, and this is a YARA rule that Grok did for the same sample. Now, all Grok has done is take the YARA rule from ChatGPT and change the variable names, which we all know is the most classic trick to avoiding plagiarism. Everyone does this to trick their lecturers, and then change the author. That is the only legitimate change here. So it's completely ripped off the other one, which from an AI model created by Elon Musk, isn't that just the most typical thing? Of course, his little baby is stealing other people's content and just writing it as their own. That is just, when I found that, I was actually blown away by it. So I had to change my whole methodology for doing this and essentially write the outputs of the file, of the AI enrichment to a different document so that Grok wouldn't have access to them and wouldn't be able to copy them. And then I started getting really quite good results. It was performing better than the other models, which I was quite surprised by. You can see here from this YARA rule, it's quite complex. It's looking for file signatures, file headers. It's looking for specific payloads and various IOCs. This is some quite good YARA rules. It's even looking at the file size of things. So clearly it's quite. I was surprised because if it just did its own homework, it would be getting better marks. So it was a bit of a shock to me, honestly. Like I was mentioning earlier, packed malware is always going to be a tough thing for AI models to analyze. But even still, I think this was made by Gemini. No, it's made by DeepSeek. This is a packed malware. Obviously, there's no IOCs to actually look at in the sample itself, but it has managed to find the file header for an APK, and done this check here to basically see if it's got high entropy, indicating it's packed. And it would detect basically any APK on your system that is like packed, but still, it's better than nothing, and I was slightly impressed. So at the end of the day, really, AI is not too bad at malware analysis. It's not too bad at Yara. It sort of made me stressed out, because it's like, I kind of wanted to prove for this talk that AI wasn't really good at this sort of stuff. Like, my job's safe, I won't be fired soon, AI is shit. But I sort of proved the opposite. I was like, oh, it's quite good. So it wasn't the best results, but I'm very happy with the product I developed at the end. And like I said, I use it all the time now. Since I was playing with so many different AI models, I did decide to do a cheeky little tier list just to like compare it, because I was playing with them a lot. Let's start with a solid C tier, or as B tier, getting DeepSeek in there. It is a rip-off of ChatGPT. It just didn't really perform as well. It wouldn't give me the best results at the end of the day, and I wouldn't really use it again in future detections. ChatGPT, solid A tier. I think probably mainly because I'm paying for it. That's the only reason it's good. But still, it provided decent results. I would say it was like solid middle of the pack. As much as I dislike the Muskrat, his AI model was by far the best one. It was like producing really, really detailed results that like I preferred. In fact, when I come to like finish this product, because obviously it's not finished, I'm in cybersecurity, but when I come to finish it, I think I will try and use Grok as the AI enrichment for this project. Hopefully I won't have to pay for it, but we'll see. And solidly at the bottom is Google Gemini. This thing is terrible. Honestly, it would produce just like slop every single time. It was by far the worst one. And
you try like Perplexity or White Rabbit?
I've not tried those at all. That's the first time I've heard these words. So.
I think White Rabbit is one that I think some cyber companies are using, but Perplexity is one my friend uses a lot.
Okay.
She does it works with cyber prism, so they're using a lot.
I'll have a look at them afterwards.
Yeah.
Anyway, like I said, I didn't finish everything when it came to this talk. This is my first talk. I didn't realize it would be this much work, honestly. Like, I was up till 3 in the morning last night finishing these slides, absolutely stressed out my brain. Some things I was working on to add to this. Everybody in cybersecurity hates reporting. That's the worst bit, having to write up a report. And I've actually got it working quite well, where it's, like this is the output from one of the samples, where it was outputting the various stuff into a Word document, and basically setting it up all for me so that I can just open the document and start working on the basic dynamic analysis. I wanted to add a couple more tools to the doc. I didn't want to I found that actually adding like multiple tools with duplicate results would confuse the AI models. They would tend to repeat themselves, so I erred on the side of caution and like remove some tools. But I would like to add some more tools to give some more deeper insights. And I was working on a sorting feature so that I could pick the funnest ones, so that I wouldn't have to look at all these boring samples over and over again. I do think that we're going to see more and more inclusion of AI into our tool sets and stuff. We're already seeing it with stuff like Microsoft Defender. It's been using AI to provide detailed behavior analysis of samples, and it's actually quite good at detecting 0 days. Stuff like CrowdStrike, other tools, they're all going to be incorporating AI. I know we hate it. I know we disable it as soon as we see a new AI feature, but I think it's going to be natural. It's going to be incorporated into everything. It was slightly out of scope for this project because it mainly relies on GUIs and stuff, but I did want to include some more dynamic analysis. I can't really see it being effective at this point, but I was reading some papers about basically like an AI backseat driver, which as you're analyzing a sample, records the key information and gives you things. Because quite often when you're looking through like let's say processes created by the sample, you can miss stuff. It is all common. We're all human. If you're looking through thousands of lines of processes, you're going to miss stuff in general. So I feel like AI can benefit in these aspects, but this is all future work sort of things. We are seeing as well LLMs created specifically for malware analysis, which seems to be the trend. We're seeing a diversification of AI models for different specific goals. This is Malware.ai, which provides nice, it provides like graphical details about samples that you provide. I did try playing with this a couple times. I wrote a little key logging script using ChatGPT, honestly, and uploaded it to it, but it wasn't really providing the sort of stuff I wanted to, and it was a bit last minute. When I say last minute, it was last night, so I decided not to include it in the final stuff. Anyway, I'm going to sort of wrap up here because I see my time's coming to an end. But what did I learn from doing this project? Well, I found that automation, as we all know, is the best way to get rid of the boring bits. And especially with this problem of the flood of malware we're seeing, where it's half a million new detected malwares every day, automation is key to keeping on top of these things and staying up to date with this arms race. But I also did find that it can never really replace the investigation properly. An analyst will always be needed to give those insights, to give those like proper sophisticated responses and understand what the sample is trying to do at a deeper level. AI is of course great for providing categorization and classification. It did exactly what I wanted it to do by basically showing me exactly what I was looking at before I even started. But also lacks the sophistication to write up a report properly. It's never going to be proper. The Yara rules that provided would always need editing because they were always a little bit too basic. But it's still a good tool to incorporate if you're wanting to save some time. And I think finally, the combination of AI and automation is just like a match made in heaven. It's just like, it just works so smoothly. It can save a load of brain power, a load of time. It's just amazing. And I think we're going to see more and more AI in malware analysis. It's excellent at detecting 0 days, like I've said, new emerging threats. I think it's just a fantastic resource that we can use. So I think that is honestly me done. I think I'm done. Anyway, I'll take any questions if people have them.
So, thanks, this was really helpful. I didn't see a ton of numbers in the sense that, like, we know that the error rate for any of these large language models is higher than 0.
Yeah.
And so, you know, some of the things that's going to be bang on, some of these things is going to be a little bit wrong, and some of these is going to be way off. And I didn't see, like, number of trials that produce an error. So how was it you come up with a tier list, and what's the math on it?
It's purely subjective, honestly, you know? Like, I was doing this in my spare time between shifts, and I was just wanting to upgrade it, and it then eventually spiraled into becoming a talk. So I didn't really record numbers. I know I should have been more scientific with my methodology and stuff, but...
Well, the error rate is so high that people just messing around experience ridiculous errors. So it's not like, you don't have to try really hard to get an error. And so it would be interesting to know, like, what % of the time is it actually right?
I think there's a good future talk in that, honestly. Like doing this details into like which AI models are producing a higher error rate. I was mainly, honestly, just trying to get this working. You know, like that was the stressful bit. So, any other ones?
So, I guess it kind of like bounces off this idea, but would you recommend that, like, say, like a beginner analyst is working in a company? Would you recommend that they maybe do the legwork first of like really learning how the statical dynamic works, and then maybe move to the like automation AI side so you can
I think so.
Like,
I do agree, because you can become complacent with AI. You can just let it do the stuff for you and ignore it. I do think you need to understand the basics before. You need to be able to do static analysis and understand what you're looking for before you can actually just get the AI to automate it. You know, after you've analyzed like 50 samples, you know what you're looking for, you know what it is. But if you're just starting out, this would be more of a crutch than anything. This is doing the work. You're just like repeating what it's saying. So I do agree with that. So.
Yeah, thanks. So I was wondering, like, actually, I was surprised that you left out most obvious choice of AIs, namely that you samples that train your own AI specifically. It actually, for this purpose, probably it's a small language model, and so you get way better results than the generative AIs out there. And I'm actually in the business of developing small language models for companies, and that's why it was like mind-blowing to me that for this specific subject we didn't even touch and try to self-host and train your own AI for this very subject. So take a Mistral 7B, let's say, that is pretty much a generative large language model, and just train it and fine-tune it with your own high-quality data.
Well, I think that is a good aspect of future work for it, but for me, I was just trying to find like a nice, easy solution to implement using existing tools into my own system. So I was wanting to see how good ChatGPT and these other AI models were at analyzing these things. But I do agree that like a malware analysis AI would be far superior at providing better detection
Yeah,
of
you
better
can
stuff.
compare with the like ChatGPT
Yeah.
because you can pick and choose the high-quality data in that case.
Yeah.
Meaning that all the trash that you don't really know what ChatGPT used for their training, but you can filter them out instantly. So in other words, that's kind of a result-oriented approach rather than just messing
Yeah.
around and see if you
Well,
know.
I did go into this project thinking of it more of like a scrap heap challenge sort of thing. I just wanted to combine a bunch of stuff and see if I can provide something that will save me time and make my analysis easier. So that was the sort of goal of the project. I felt like that, creating my own LLM, you know, training it myself, is a little bit out of scope for this stuff. So.
Okay, just one follow-up thing, just because you put on the screen Taiwan, about Taiwan and DeepSeek and what DeepSeek actually gets back to you. I see similar thing on LinkedIn that tell me about the Tiananmen Square massacre and
Yeah.
but I was surprised that technically savvy people are using the large language models of Google. If you have a right prompt, actually I get a proper description of the Tiananmen Square massacre from DeepSeek, just because I use the prompt rather than just using a Google.
I hadn't seen that, but I also do think that if you're having to use a specific prompt to get an answer, otherwise it's outputting a wrong answer, that's not really like indicative that it's not biased. I feel like it is showing that it's still biased. It's like if you're having to find a
specific prompt doesn't mean that you need to just tell me about how many people died there, but let's say just shape it in the way that you are as a historian, you need to describe this specific time period or whatever. So it's not just a Google, it's a large language model, so you should use it, I believe, as a large language model as opposed to using a search engine.
Okay, all right, very nice. Well, we'll move on to another question. Colm.
So when you're looking at the threat actor, so using ChatGPT prompts that they were like content vectors, did you run the risk if you're also feeding that on your side that makes content or eventually?
What do you mean by that? Sorry.
So if the threat actor is using ChatGPT to generate the malware or whatever,
Yeah.
and you're using ChatGPT to help you analyze the same malware, eventually would it not be more beneficial for both parties just to not use it?
Well, like reach like a deadlock where you can't do it anymore. I do feel like that is sort of the whole thing of like an arms race, you know, like if they're using it, we need to use it, and then it sort of cancels each other out. So you are kind of right. But I do feel like the detections are very different from creating the threats in the first place, you know. It can create these sophisticated malware payloads to execute, but we can also create these detections that catch all these things. So it's sort of, it's sort of deadlock, but also we both benefit from it, so.
I have a question regarding for clarification. Have you tested your project now on Gemini or Microsoft Copilot? Because
I use Gemini.
you know a lot of Copilot, but you told us to use Gemini.
So I use Gemini for it. Yes. Any other questions? John?
Well, from engineering, you said you gave us really short tricks, but have you tried driving the model or telling it that if it doesn't do a good job, you get fired? It really helped.
I'm trying that right after this, okay? I'm going to print Lord Sugar on the AI's ass, all right? You'll be fired if you don't give me this right now. So, anyway, one last one about.
How vulnerable do you think this kind of thing is to deliberate poisoning as this becomes more widespread? You know, the equivalent of dumping strings in that tells it to go quite aggressively for bait, you know, so that when your initial pipeline is feeding that out, it's kind of disrupting this subsequent analysis.
Sorry, I'm not sure. I don't quite get the question.
Sorry, so obviously with like the AI models at the moment, we're seeing poisoning of it and sort of the back and forth of trying to interfere with the way that the models will interpret the input. So do you think that this is vulnerable to that in terms of the malware authors all the LLMs and so on within their samples, like basically before coded, go make your cake recipe kind of thing, as that art-based continues.
I don't feel it's vulnerable in that aspect because I'm keeping everything very static. You know, I'm not executing anything. I'm simply analyzing the contents of it. And it's not like it's creating like somewhere to execute it in. So I think it is something I thought about of like, what if someone sees this research and then creates a specifically crafted sample to target this? But I do feel at this point it's not really realistic that something like that would happen. So. Anyway, is that done? Oh, thank God.